Here's an old oscilloscope a friend of mine who pulled out of a dumpster for me. Doesn't work. I've tried it. It's completely dead. There's probably, unless there's a bad fuse, I'll check those out, but it's probably a problem with the power supply. I don't know anything about the history of this unit, but being completely dead, there's probably a good chance we can get it fixed. So only going up to 25 megahertz. It isn't a real high-end scope, of course, but these are nice for working on low-frequency circuits or audio circuits. So I'm going to take it apart and let's see if we can get this thing fixed. Well, I removed the power supply from the unit, and looking it over here, something that doesn't look too promising here. Check this transformer out. You've got some insulation here on the transformer. I don't know if we've got any shorted turns. If this transformer's bad, this is basically a donor scope. You'll never find another transformer like this. But I also found just a cursory observation here. I got two transistors that are bad in the power supply, and they're the power transistors that drive the output transformer here. So we're gonna try to find out what's wrong with this thing here. If it's this transformer, like I say, this thing is basically toast. So first of all, let's look at the power supply, how it operates, and then I'll see if I can find some subs for these. It's worth trying to fix this thing. It's not a real high-end scope. Obviously not Tektronix, but other than the bad supply, it looks to be pretty good shape. Here's a schematic of the power supply. You've got your main transformer here. Line voltage comes in. It is stepped down through the secondary. Bridge rectifier of V2, 01, 203, 202, and 204. They convert the AC to DC, supplying a negative voltage to this top rail, positive voltage to the bottom rail. And the way this works is, once you turn on switch S17, you supply negative here, you get a negative voltage down through this divider. This turns on V216. This is a PNP transistor, so the negative voltage turns this transistor on, and that supplies a positive voltage up through the transistor to the base of V214. Now the collector is blocked by this diode, so you're basically using just the base emitter diode as a diode, and since the base is positive, it's forward biased, so you're applying a positive bias to the both bases of these transistors. Positive with respect to this point here. So what happens is, when you turn it on, one of these transistors is going to conduct heavier than the other, since they're not going to have the same gain. Let's say this one has a slightly higher gain. This starts to conduct, which supplies negative voltage through the transistor, comes up through the primary winding, the lower primary winding, back to the positive rail. But at the same time, that negative voltage comes up through the primary of T2 201, down through V219, and charges C208. And what that does is it induces a current that provides positive bias, increasing the conduction of this transistor. So the current continues to increase in the primary winding, the lower winding here, and it also continues to increase here until T201 saturates. At that point you lose the bias, and this transistor ceases to conduct. Then V217 will begin to conduct, apply negative voltage through the top winding. Current flows through the top winding back to the positive rail. But at the same time, you've got a negative current that will flow down this time through the primary, and this time up through T221. That will increase the conduction in 217 until this core saturates, at which time current flow stops, and it just goes back and forth. One will conduct and then the other, and that's how you get your AC current started in the primary. This runs at about 18 kilohertz. So how do you regulate that voltage? Well, since you have an AC current flowing in this circuit here, these two diodes will conduct alternately and charge up C2209 to a positive potential, here at 20 volts. And that voltage is supplied up through this resistor and two stabilizers to this pot. These are just voltage references. They're both in series. They act like a Zener diode, but they're basically like two diodes in series. These are old components. I don't know if they even make stabilizers anymore. But anyway, by controlling this pot here, you can go from the negative to positive. You can control the conduction of V216, which supplies the bias, the normal bias, up through this transistor. So as the voltage goes up here, the positive voltage goes up, which will cut down on the conduction of this transistor. It's a PNP, so a positive voltage supplied in a positive direction will cut the conduction down. And that's how it regulates. And of course the output, you've got all your different windings have separate diodes to rectify for the different windings. You've got 5, 12, 38, 180, minus 115. And then there's a voltage quintupler up here that will, it's off the chart here, but anyway, it's a voltage multiplier that raises the voltage, the high voltage for the CRT. Only other components in here you've got, well, here's your main capacitor. It's a large capacitor here. Was it 2350 microfarad, and that charges across the two rails here. This is probably a bleeder, and this transistor here, this is for the gradical illumination. When you close the circuit here, the main switch, it's also gained to this pot, and by controlling this pot you control the current through the two lights on the gradical illumination here. So that's basically how it works. Of course, you've got different primaries you can connect for any primary voltage you need. So anyway, these two transistors are bad. What I'm going to have to do now is find a substitution for those, and then I'm going to have to test other components in here because we might have some other problems in here. My only concern is this transformer here shows, as I showed in another scene here, has a problem. And I don't know if there's a short or an open. I don't know what the problem is because this has never worked, but maybe this just cracked open. I don't know. It doesn't smell like there's been any burning or anything like that. This transformer here is T202, and this little transformer here is T201. So if T202 is actually bad, this is basically a donor scope. Anyway, this circuit is schematic here, and this is your main capacitor, which is here. Some other things, you've got some inductors here, which are inductors in your, you got a pi filter here on these two, or these three outputs have a pi filter, which is here. I'm going to check all these capacitors too. Fuse is good here. So hopefully they just opened and didn't burn anything. I don't see any sign of any burnt components on here. These are the two stabilizers. They look like diodes. They're basically, you know, just for voltage reference, and temperature stability too. So anyway, next step will be to replace these two transistors, which go here and here. It's kind of funny how they did this. They're, well, I can show you when I put it back together, but the two transistors go onto two little heat sinks. They go through these two holes. Different way of doing it than they do, for instance, Tektronix, but seems to be well made, well constructed. All the solder joints seem to be well. I haven't found anything that looks bad yet. So anyway, stand by. We'll see what we get. Here's the two output transistors, V217 and 218. They're NPN transistors, and from left to right it's emitter, collector, base. So measuring from the base to the emitter, it's an open circuit. Base to collector, we have a short, both directions. Base to collector shorted, and the emitter to base is open. Same thing with the other one. Here's the emitter. So here's the base. Then measuring from the emitter, we have an open circuit. To the collector, we got a short both directions. It's shorted. So these two transistors, open emitter base junction and shorted collector base junction. So both these transistors are bad. The two BD37 power transistors have been mounted on the board here, and interesting heat sinks. I've never seen anything like this before. They've got these two cylinders underneath each of the transistors, and there's a mica washer, and then there's a screw on top. It's got an insulator on the shaft of the screw, and then there's a large washer on top that clamps the assembly, and then the bottom of these will go through the back of the power supply here, and once I connect it, this is the connection for the high voltage here. That will connect to this gray wire here, which goes to the CRT. Hopefully this transformer's not damaged. I don't like the looks of this. Either this just cracked because of age or whatever. Like I said earlier, I didn't smell any telltale sign of arcing or burning, but I don't like the looks of that. If the thing works, I'll put some insulation over that to seal it. But anyway, the next step will be to get this back in the unit, and we'll give it the smoke test. Okay, the power supply is installed now. All the cabling is in. And two important connections you don't want to forget if you do one of these is there's the high voltage connection on the bottom of the brown transformer, and then there's a ground that has to be connected just above the lower right screw that holds the board on. And connections made. So the next step will be to power it up and see what happens. We'll do it with a dim bulb to make sure if there's any smoke it's minimal. Well, it looks like the Phillips PM3212 repair is going to be a failure. Unfortunately, this transformer's bad. And I tried powering it up, dim bulb tester, with only a 40 watt bulb, and both transistors blew, both of these here. The two transistors that drive the output transformer. All the other parts are good. I checked everything. And the only other possible component is the transformer. So I guess this one is going to become either a donor unit, or if I can ever find another one that uses a similar transformer as this, Here's the number in case you're interested. Anyway, you can't fix them all, and some of this old stuff, depending on what parts go bad, unless you have a donor with a similar part that's in good shape, they're really not repairable. So, but I will put this one in storage, and who knows, maybe we'll find another Phillips unit that uses the same transformer. So I'll wrap this one up, and hopefully the next repair will be a success. Bye for now.